Comet 3I Atlas enters observation not with a single anomaly but with a pattern. Colors appear where they usually fade. Jets persist where dust should dissipate. Ion and X-ray tails extend farther than expected. None of these features alone would demand attention. Together, they form a case that deserves careful, restrained examination. This investigation does not begin with a conclusion. It begins with a set of observations made by an astrophotographer named Ray. Ray does not claim authority. He provides footage, timing, and processing steps. His material is treated here as source data, not interpretation. Everything beyond that is weighed cautiously. Ray's images show Comet 3I Atlas across multiple nights. The coma and tail display strong color variation. These colors are not fleeting flashes. They persist across frames and sessions. Ray notes structured jets emerging from the object, visible repeatedly rather than once. These are not single exposures or processing artifacts that appear and vanish. They are consistent visual features. According to Ray's observations, something changes after the comet passes behind the sun. When it re-emerges while moving toward Mars, new colors become visible. This timing matters. The solar conjunction represents a transition in solar wind exposure. What happens before and after that point can often be explained by renewed interaction with charged particles from the sun. That explanation is familiar. What is less familiar is the strength and persistence of the response. Ray captures this moment directly.
And I was looking at various papers that were published since then by the European Union's Clipper mission. I think that was smoking gun. I'm going to have a separate video of the Clipper mission and the details that they found. It was like fascinating of how big the ionized tile is and how the Clipper was showered by the ionized tile of Comet 3 Atlas. I'm going to create a separate video talking about the Clipper mission by itself. That's a fascinating story, by the way.
Ray describes the colors as a plasma show. That phrasing is Ray's assumption, not a conclusion. What matters here is that the colors appear after solar conjunction and are captured consistently. The observational fact is color emergence. The cause remains open. Ray also references images from other observers and satellites that show similar features during the same period. This matters because independent datasets reduce the chance that the effect is caused by a single instrument or processing pipeline. Agreement across platforms does not prove cause, but it strengthens confidence in the observation itself. Among these external datasets, Ray highlights images associated with the Clipper mission. According to Ray, these images show a very large ionized tail connected to Comet 3I Atlas. He also notes that the Clipper spacecraft encountered a dense region of ionized material associated with the comet. This is not a casual claim. Spacecraft interactions with cometary material are measurable events. Density, charge, and extent can be inferred from instrument response. Ray addresses this directly.
The pictures from the Clipper shows very clearly that it was dealing with a lot of ionized gas and ionized tail of Comet 3 Atlas. And when we were taking pictures almost the same time, we were looking at all these colors.
Ray's footage is temporally aligned with these spacecraft observations. His imaging occurs around the same time that Clipper and Chandra record extended ion and X-ray tails. Timing alignment does not establish causation, but it does establish correlation. When multiple instruments observe unusual ionization during the same window, that window deserves attention. The Chandra X-ray observatory data, as Ray notes, shows an unusually long X-ray tail. X-ray emission from comets is not unheard of. It typically arises from charge exchange between solar wind ions and neutral atoms in the cometary atmosphere. However, tail length and brightness vary widely. What Ray points out is not the existence of X-rays, but their extent. At this point, a mainstream explanation remains available. Standard comet models attribute color, ion tails, and even jets to solar wind interactions with sublimating gases and dust. Fluorescence, ionization, and outgassing can produce a wide range of visual effects. This explanation is not dismissed here. It is accepted as the baseline. Accepting that explanation raises a question rather than closing the case. If standard models apply, do they account for all observed features without strain? Ray's imagery suggests structured jets that appear coherent rather than chaotic. Sublimation-driven jets are typically irregular, changing as surface ice warms unevenly. The jets Ray documents appear persistent across time. That persistence alone does not falsify standard models, but it narrows the range of conditions required. Another feature Ray highlights is apparent rotation. He does this not through speculation, but through processing. Ray explains his image processing steps, including slow-motion playback of a sequence. In that slowed sequence, the object appears to spin. Ray captures this moment carefully.
So this picture that I have here, if I run this on the slow motion, you will actually see it is spinning, right? What causing it spinning, whether somebody can prove it definitely that it is spinning, does it have a shape? I mean, those are all still need to be researched. We have enough data now, we captured enough data, and we will provide this data to.
Here, Ray explicitly states uncertainty. He does not claim proof of rotation. He acknowledges that the cause and even the reality of the motion requires further research. This distinction matters. Apparent rotation can result from perspective effects, uneven outgassing, or processing artifacts. Without independent confirmation, rotation remains an open question. Ray then moves into speculation. He suggests that plasma interactions could explain the observed colors, jets, and tail structure. He proposes that the jets may function similarly to a plasma thruster. He speculates that Comet 3I Atlas could be interstellar, possibly carrying ionized material from another star system. These ideas are clearly framed by Ray as hypotheses, not conclusions. This investigation follows the same discipline. What Ray assumes is separated from what he observes. Observed facts include color persistence, structured jets, temporal alignment with solar conjunction, and spacecraft measurements of ionized material. Assumptions include plasma-driven propulsion, interstellar origin, and technological implications. Unknowns include composition, mechanism, and statistical rarity. The interstellar question deserves careful handling. Ray suggests the object could have traveled from Sagittarius, from deep within the Milky Way, or beyond. Interstellar objects do exist. Oumuamua and Borisov established that fact. However, interstellar origin requires orbital analysis, velocity measurements, and long-term tracking. Ray does not present that data here. Therefore, interstellar origin remains speculative. Even without invoking interstellar travel, plasma physics still enters the discussion naturally. Plasma is the most common state of matter in the universe. Solar wind is plasma. Ion tails are plasma structures. Recognizing plasma does not require abandoning mainstream astrophysics. It requires acknowledging that plasma behavior can be complex and sometimes counterintuitive. Ray argues that plasma has been underemphasized in recent decades in favor of gravity-centered explanations. Historically, plasma physics and particle physics have alternated in prominence. This context is interesting, but it does not alter the data. What matters is whether plasma interactions at this scale can account for what is observed. One contradiction Ray highlights is tail length. The ionized tail measured by Clipper appears unusually dense. If confirmed, this would place Comet 3I Atlas toward the extreme end of known comet behavior. Extremes do not invalidate models, but they test them. Another contradiction is color intensity. The colors Ray documents appear sustained rather than transient. Transient color bursts are common during outbursts. Sustained emission suggests either continuous replenishment or stable interaction conditions. A third contradiction is coherence. The jets appear directional and organized. Random sublimation tends to produce more chaotic patterns unless guided by specific surface geometry or magnetic interaction. At this stage, plausible natural working theories remain available. One possibility is enhanced plasma interaction due to unusually high ion content. Another is a rare compositional structure rich in easily ionized material. A third is extreme coupling with the solar wind during a narrow timing window. Each of these explanations fits within known physics. None require technology. None require intent. They do require more data. What data is missing is critical. There is no direct spectroscopic confirmation of plasma composition presented here. There is no independent verification of rotation from a separate instrument. There is no quantitative comparison placing this comet statistically among others observed under similar conditions. There is also the issue of observation window. Comets change rapidly. The features Ray documents may evolve or disappear. Without continued monitoring, patterns can be misread. Ray states that he intends to share his data with others for further research. This is appropriate. Open data allows independent verification, which is the only way speculation becomes science. As this observation window closes, what remains is a boundary case. Comet 3I Atlas does not prove a new model. It does not overturn existing theory. It does something quieter and more important. It highlights where certainty thins. This object sits at the edge of what current comet models comfortably explain. That edge is where refinement happens. Whether future data resolves these features into known categories or forces new ones remains unknown. For now, the most honest position is restraint. Ray's footage shows something unusual. His interpretations invite curiosity. The data neither confirms nor denies broader claims. In astrophysics, uncertainty is not failure. It is the signal that observation has reached the frontier of explanation. As Comet 3I Atlas continues its journey, the window for observation narrows. What has already been captured remains valuable, not because it answers questions, but because it asks them clearly.